Hello, Accelerated Math 7-8 students. This is Module 8, Lesson 2 that we are going to do today. The lesson is called Adding Integers and Other Rational Numbers. Notice that I am showing you the table of contents first today because I want you to make sure that you remember that every title of notes that you write in your comp book has to be recorded under your table of contents. You also need to remember to include the page number that it starts on. For me, adding integers and other rational numbers begins on page 9. I am going to turn to page 9 right now. Okay, here is page 9 for my notes. We are still in Module 8, okay, and we are completing Lesson 2 today. Adding integers and other rational numbers. Our goal for today we are going to learn how to add integers and other rational numbers with different tools. Okay? Pretty simple. We're going to talk through that together. Here we go. The question that I want you to be thinking about during the lesson and also be able to answer at the end of the lesson is, what are the rules for adding integers? There are quite a few. We're going to go over them together. But before we go over them, there are a couple of tools that I want you to keep in mind that will help you understand this. A couple of tools for adding rational numbers include a number line is one of the tools, and an equation is the other tool. That's why we're doing a couple. Okay? So, a number line can be a very helpful tool when you use arrows. Okay? Arrows on a number line tell the length, the direction, and the sum. The length is determined by how many units the arrow spans. So if we have a number line, I will draw one right here on the paper, and we've got to write our numbers on there. We have 0, 1, 2, 3, 4, okay? And then if I draw an arrow to represent a span of numbers, I always start at 0. So I'm going to start at 0, and let's say I draw an arrow that long. So what does it mean when I say arrow spans? Well, what that means is how many units did it draw, or how long is it? So let's count the units. 1, 2. So this arrow right here represents 2 units. Okay? You can also have arrows that go the opposite direction. Sorry, my number line is not equal, but I'm trying to go fast. Okay? So again, we would start at 0, and let's say that I draw this line this time. How many units does this span? 1, 2, 3. So this one is 3 units as well. Okay? So that's what it means when length is determined by how many units an arrow spans. Second thing, the direction. The direction is very important because the direction tells whether the integer is positive going to the right or negative going to the left. So let's again look at these two arrows. This arrow is going to the right, so the value of this arrow is a positive 2. So the value of that arrow over there, that one right there, the value is a positive 2. The value of this arrow right here, and I know this is confusing because I'm drawing more arrows, but the value of this arrow right here is a negative 3. Now the reason why is because this arrow is going to the right on the number line, this arrow is going to the left on the number line. Okay, so hopefully that's pretty clear now. The third thing is the sum of the arrows tells the final position. That's hard to see. It's falling off. Let me fix it. Okay, so the sum of the arrows tells the final position when we have more than one arrow working together. And if you'll remember, in math, sum means that we're adding. So we're obviously adding two things together to get an answer. So let's try one really quickly. Again, if I draw my number line, here's my number line. Okay, and let's say that we have a negative 2 as one of our integers and a positive 5 as another one of our integers. Okay, that's a different drawing, don't worry about it. So the way that we do this is, number one, we have to draw our number line. Okay, So let me put some values on our number line. So this would be -1, -2, -3, -4. And then we need to go this way. 1, 2, 3, 4. Okay, hopefully you're all with me. The first integer that we're given is a -2. And remember I said that when we're drawing our arrows to begin with, we always start at 0. So for this integer right here, we're going to start at 0. We are not going to start at 0 for the 5 because up here on our paper it says the sum. So that means that we are adding these two integers together. So to draw it on our number line, you're going to start at 0 and you're going to represent an arrow that is -2. So I'm going to go to the left for 2 units. Hopefully everybody sees that. Then I'm adding to it a +5. So which direction was positive? That is correct, to the right. We do not start back on 0 because we're adding it. So we start right where we are and we go 5 units to the right. 1, 2, 3, 4, 5. What integer did we land on? Well, we stopped at 3. So the answer to this problem is 3. Okay? So that is what we were talking about when we said the sum of the arrows tells the final position. When we finally stop drawing our arrows, where did we stop? At 3. So we circle it, and that is the answer. That is the sum. Okay? Again, when you're starting to show a mathematical problem, you always begin your first arrow on 0. Okay? So, for a practice that I need you to have ready for Thursday morning is, Thursday afternoon when I see you in class, sorry, I would like you to show me on a number line, show 4 added to -7 on a number line. We will be checking it when you get into class, so you need to try it right here at the bottom of your page. Okay? All right, quick preview. Not going to show you too much on that one because I want you to do it by yourself, but I am moving on to the next page. So the next page in our notes, again, we're starting a new page, so I have to put the title, Adding Integers and Other Rational Numbers. We talked about in our goal about having 2 tools, okay? So the second tool that I'm going to teach you about right now is called an equation. We are going to use equations with verbal descriptions. So equations using verbal descriptions. You all are pretty familiar with what an equation is. I don't know if you know too much about a verbal description. In math, a verbal description is basically a math problem that's written in words. Okay? So let's check this out. Math written in words instead of symbols can be very tricky. The use of equations makes it a lot easier. Okay? So for example, here's a math problem. Let's read it together. The sum of -8 and 6 is what number? So if you actually listen to those words, it's telling you a math problem. Your job is to figure out what that math problem is, write it, use one of the tools, and then solve it. Okay? So here are some steps to take to be successful with it. The first thing that I want you to do is you need to circle the important words. Well, let's go back. I'm not going to circle on here, but I would like you to circle on yours. Which words in here do you think are important? I think that sum is very important, so circle that. -8 is very important, so circle that. And because we're finding the sum, we know this word and must be a plus sign, so I would circle that. 6 is obviously important because that's the second number being added. Is in math always is the equal sign, so that one's important. What number? Leave a blank. We don't know. Okay? So we circled all the important words. The next thing that you need to do, and we talked about this a little bit on Monday's class, setting up a blank equation. Well, setting up a blank equation is when you use blanks. And since this is the sum, we know that we need to have blank plus blank equals blank. That's what it means right here when it says set up a blank equation. The next step, fill in the given values. Okay, the sum of -8, so what goes on the first blank? You are correct, -8. Plus, right here, and 6, so 6 goes on the next line, is what number? So we just leave that blank because we don't know what it is. All right? And now that we have our sentence starter or our equation that's not finished, we can now solve it. You learned a technique with the number line and arrows on the previous page. I'm going to show you one more so that you have another one to use if you like it. It is called the chip method. The chip method is called the chip method because I have chips that I'm going to show you when you come to class on Thursday, but the chips are colorful. They're red and they're yellow. On the yellow side, there is a plus. On the red side, there is a minus. And basically what you do is you draw the number of chips for the integers that you have. So let's try it. If this says -8, then I need to draw 8 circles because those represent the chips. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. And they are negative, so all of these have to have a negative sign on them. So -8, that's my picture. Then it says a +6. So again, I'm going to draw 1, 2, 3, 4, 5, 6. And then these guys are positive, so I'm going to put a plus on them so that everybody knows that those are positive. Now, I want you to think about something. If you're putting batteries into a remote, let's say, if you do not put the battery in either the positive or the negative side correctly, does the flashlight turn on? The answer is no, because the battery is not correct. Well, in math, what we learn about the positive and negative numbers is that when you have one positive right here and one negative, if you were to put them together, they cancel out, which makes a zero pair. They're called zero pairs. They don't really cancel out, but they just they negate the value of both, giving you nothing. Well, what number is represented by nothing? 0. So this positive combines with this negative and creates a zero pair. So we put a 0 around it. This positive combines with this negative, so it creates another 0 pair. So we put a 0 around it. This positive joined with this negative creates a 0 pair. This positive with this negative creates a 0 pair. This positive with this negative creates a 0 pair. This positive with this negative creates a 0 pair. So we have, if you count them, 1, 2, 3, 4, 5, 6 zeros. Well, 0 plus 0 plus 0 plus 0 plus 0 plus 0 is still 0, isn't it? Aha! But we have these two little guys left over. They are there. They didn't go away. You don't just get to sweep them off the page and say they're not there. This, the leftovers, is your answer. So -8 plus 6 equals what, everybody? That is correct, -2. Okay? And what this process is called is the chip method. So in your comp book, if you take a look, I already have the chip method drawn for you. Okay? And hopefully, while I was teaching you it, you were doing it. Okay? So this is called the chip method. All right, so now we know how to figure out equations using verbal descriptions. And now, kiddos, we are going to learn the rules for adding rational numbers with the same sign. Okay? This up here is not an example of that. This one has a negative, this one has a positive. So this right here, rules for adding rational numbers with the same sign, this is not an example of it. An example of that would be, let's take a look. When you are adding a positive number and a positive number, your answer is a positive. So basically the way we look at it is a positive plus a positive equals a positive. Well, that makes sense. Let's try it with numbers. What if I give you 2 plus 4? Is 2 positive? Yes. Is 4 positive? Yes. So what is the answer of 2 plus 4? 6. Is 6 positive? Yes. So now we know the rule that if you have a positive plus a positive, you get or equals a positive. Pretty simple. You already knew that one. You learned that one in 2nd grade. When adding a negative and a negative, you get a negative. There's no way you can get anything else. the answer to a negative plus a negative is a negative because all you have is negative. Let's do that with the chip model to show. So if I have -2 plus a -4, what do you think my answer is going to be? Well, let's draw it and see. So I have 2 negative chips right here. That represents what you see. And then I have 4 negative chips right here. So I'm drawing 4 negative chips, just like I taught you before. And it says add them, so you're going to tell me how many you have altogether. Well, count your negative chips. 1, 2, 3, 4, 5, 6. So what's my answer? -6, because I only have negatives. So this proves right here our rule, when adding a negative and a negative, you get a negative. So a negative plus a negative gives you a negative, equals a negative. Good? Hope so. Okay, let's keep going. Now we're going to mix it up a little bit and make it a little harder. This time, we're going to be looking at a rule for adding rational numbers with different signs. Different signs. Okay, well, this guy right here is an example of that. This one is negative and this one is positive. So this is exactly what we were talking about earlier in our lesson. A rule for adding rational numbers with different signs. Okay, so let's read this and hopefully you won't get confused. But if you do, you have me. That's why you have me. When adding a positive and a negative, you take the sign of the number with the greatest absolute value. Okay, let's think about this. You take the sign of the number with the greatest absolute value. So before we start adding anything, we have to figure out the number that has the greatest absolute value. Do you guys remember what absolute value is? I'll give you a hint. If I draw this, what does that mean? Oh, you can't see it. Now you can. What does that mean? That means that the distance from 0 to -8 is how far? 8. That's right. Okay, if I take the absolute value of 6, what does that mean? The distance from 0 to +6 is 6. Remember, kiddos, distance is always positive. So which one out of the two is the greater absolute value? Ta-da! -8 is. Okay? So we know already that our answer is going to have a negative in it because -8 has the greater absolute value. That's what that means. Okay, and now we just use our tools. Let's try the number line again to see if you remember it because I haven't done it for a while. Okay, so again, we start, when we're drawing our arrows, the very first one, we always start at 0. So let me get these written in real quick so you can see what I'm doing. So -3, -4, -5, -6, -7, and I fell off the page. I'm so sorry. -8. Okay, so Mrs. Nelson said I had to start at 0, so I'm starting at 0 and I'm drawing an arrow to the first number, -8. Okay, now I'm adding. So adding means that I have to go to the right because you're increasing. And the only way we increase on a number line is to go to the right. So I need to start right where I ended, which was -8, and I'm adding 6. So here I go. Count with me, everybody. 1, 2, 3, 4, 5, 6. And I stop. Okay, where did I stop? Draw a little line down and circle your answer. Ta-da! What answer did we get? -2. So were we correct? Is there a negative? Is the absolute value of -8 greater than the absolute value of 6? Yes. So the answer is negative, and the answer is -2 because that's where we found it. Okay. Chip method, really quick, just to make sure you remember that. 8 negatives, 3, 4, 5, 6, 7, 8, plus 6 positives. 1, 2, 3, 4, 5, 6. I think we just did this problem. Okay, so 6 positives, 0 pairs, so here's a 0, 0 pairs, so here's a 0, 0 pairs, so here's a 0, 0 pairs, here's a 0, 0 pairs, here's a 0, 0 pairs, here's a 0. Dun, da, da, da! The answer is -2 because I have 2 negative chips left over. So do you see how we proved it twice? 2 different tools, 2 different ways, and there you go. Okay? Hopefully you're feeling pretty good about this. The example that I did in here was I said 3 plus a negative 11. So we have to find the absolute value of 3. The absolute value of 3 is 3. Negative 11, the absolute value of negative 11 is 11. So which one is greater? 11. What is the sign of negative 11? Negative. So what is our answer going to be? Negative something. Your job for tomorrow afternoon when you come in, remember how I told you were going to have 3 to 5 problems to figure out? Your job is to find the answer to this problem using either method, the chip method or the number line. Okay? And that's all I'm going to show you because the rest of these notes shows you the answer, and I don't want to do that. Okay? So it says the absolute value of 3 is 3. The absolute value of negative 11 is 11, which we just talked about. 11 is the greatest absolute value, so the answer is negative. And then I showed the answer on the number line under here, so I am not going to show you because I want you to do it on your own. Do you have to use the number line? No. Can you use the chip method? Yes. Whichever one you love the most is what you're going to do. All right, that's our notes, believe it or not. Okay? I would like you to go back very quickly with me to our question of our lesson. Our question of our lesson was, what are the rules for adding integers? I think you know them. Let's say them really fast. A positive plus a positive gives me a positive. That's right. A negative plus a negative gives me a negative. Nice job. The other one's a little bit trickier because we have different signs. Who remembers what that one was? A positive plus a negative equals the answer with the greatest absolute value sign. Tricky, tricky, tricky. Hopefully you've got that. If you don't, go back and review it again. All right, my darlings. I hope this lesson went well. I hope you understand. And we will talk about it on Thursday. Talk to you later. Bye.